Hi, this is Tom, and we're going to return to our variances here, and we're going to make one more calculation, just one more. And what we're going to do is we are going to calculate s squared. And I forgot to tell you what it is. Its name, it's called the sample variance. So whenever you're given a data set that says that consider the following sample, you should be calculating s squared. So let's do that. We're going to do that here together. And remember, let me just erase that and let's just bring our data set back down just so that we have it, so we can see it easily. The data set that we were using is right there. So here's our sample data set. So for a sample data set, we're going to calculate a sample variance. That seems like a good connection. So let's do that. There's our sample data set. Let's put it right there. And here we go. So we're going to calculate s squared. So we remember this s squared is the sum of the data minus the mean squared divided by n minus 1. So here we go. Our first data value is 0 minus, and we said that our sample I'll write that up here, our x bar we calculated earlier is 3. So I have 0 minus 3 squared plus 10 minus 3 squared plus 1 minus 3 squared plus 1 minus 3 squared divided by, now notice that our data set has 4 values, so n is 4, so we're going to write 4 minus 1. Okay, then let's see, so now we calculate this out. 0 minus 3 is negative 3, we square it, we get 9 plus 10 minus 3 is 7, so we square it to get 49 plus 1 minus 3 is negative 2, we square it to get 4, plus we'll have another 4, and 4 minus 1, well, that's 3. So if we add these up, 9 and 49, that's 58 plus 8 more, we found out it was 66 divided by 3, and that is 22. So our sample variance is 22. Now let's compare this, and from up above, our sigma squared was 20.5. It's 20.5. And what happens then is that the sample variance in this case is actually even a little bit bigger than sigma squared. And that's okay. It just makes our calculations a little bit more conservative. So it's kind of makes a safe calculation. But let's do this. Let's examine the correction. And remember, the correction was that we took n divided by n minus 1 and we multiplied that by Sn squared, and the result we call now the sample variance. Well, here's why we're going to look at this correction. If I take n and then our correction, well, let's just begin with what we had. We had 4. So when n was 4, our correction was 4 divided by 4 minus 1. Well, that's 4/3. That's 1.3 repeating. Okay, let's try something a little bit bigger, like 5. Well, that's 5 divided by 5 minus 4, or 5/4. That's 1.25. Wait a minute, let's get a little bit bigger then. Let's see, 5. How about 11? Let's try 11 here. If I use n as 11, then I have 11 divided by 11 minus 1. That's 11 divided by 10. Well, that's just 1.1. So wait a minute. What if we tried something crazy like 101? Well, that would be 101 divided by 101 minus 1. That's 101 divided by 100. Well, whoa, that's 1.01. That's not much. 1.01 is very close to 1. And I'm going to go back a little. If we go right back into here at about 30, then I would put in, this is going to become 30 divided by 29. So if we take 30 and we divide it by 29, we get 1.03448276. And it goes on even further, but that's all the more my calculator will display. But the idea is this, is that when you multiply something by 1.0344, this number right here, it doesn't change the number very much. It makes it only very slightly larger. And that's the idea. And so here's what we say. We say that as the sample size n increases, the correction decreases. And eventually, S squared is approximately sigma squared, meaning they become very close to each other. And it's generally accepted by statisticians that usually a value of a sample size of 30 is pretty ideal. I hope that helps. Thanks for watching.